After getting suitable concepts or explanations on osmosis and osmotic pressure, it would be worthwhile to take up questions on osmosis and osmotic pressure. Here is an important question relating to osmotic pressure and concept of osmosis. The question is the osmotic pressure of a equimolecular solution. We call it as equimolar also. So the question is the osmotic pressure of equimolar solution of glucose, sodium chloride, and barium chloride will be in the order. And there is a decreasing order provided within these four options. We have to find out which is the correct decreasing order. Now, here you have to take care that what is osmosis and what is osmotic pressure and what are the solutes present here in this way, in these solutions. Now, you find that osmosis is nothing but the passage of the solvent molecules through a semi-permeable membrane from a solution of lower concentration to the higher concentration. And if an excess pressure is applied over the more concentrated solution to prevent the passage of the solvent molecules across the semi-permeable membrane from a dilute solution to a concentrated solution. And that osmotic pressure is given by the relation pi is equal to CRT. ये हम पढ़ चुके हैं और ये एक्सप्रेशन मैथमेटिकल एक्सप्रेशन बहुत ही इंपॉर्टेंट है. Pi is equal to CRT. C represents the concentration, R represents the gas constant, and T is the temperature in Kelvin. अब अगर आप क्वेश्चन को देखें तो we find although the solutions are equimolar, सबका concentration एक सा है, लेकिन they have different solutes. There are different solutes present in each solution. In one of the solution, there is glucose, which is an organic compound, and it will remain undissociated. The number of particles present will represented by the concentration which is provided over here. But if you look at the barium chloride or even sodium chloride, we find that it undergoes dissociation according to this equation. Barium chloride dissociates to form dipositive barium and chloride ion, two chloride ions. Similarly, sodium chloride dissociates to form sodium ion and the chloride ion. मतलब ये हुआ कि एक मॉलिक्यूल या एक पार्टिकल बेरियम क्लोराइड के केस में 3 पार्टिकल में बढ़ जाता है. It forms 3 different particles or ions. और सोडियम क्लोराइड के केस में 2 पार्टिकल हो जाता है. And now we know that osmosis is a colligative property. Means it depends upon the number of particles present in the solution. और हम पढ़ चुके हैं where there is a dissociation, we have to use a correction over the formula over here. Pi is equal to CRT needs a correction, and that correction is given by what is known as Van-Hoff factor. So we correct the formula pi is equal to ICRT, where I represents the Van-Hoff factor, and Van-Hoff factor for barium chloride is found to be 3, for sodium chloride is 2, and glucose, of course, it remains undissociated. You can say its Van-Hoff factor is 1. Now, when you put up the values properly, the value of I in case of barium chloride is 3, it becomes 3 times. Value of I in case of sodium chloride is 2. So the osmotic pressure becomes 2 times, and of course glucose has the minimum osmotic pressure, which is considered as 1. So definitely, therefore, our answer, if we put up the value of I, you get the correct answer as BaCl2 solution is greater than sodium chloride solution osmotic pressure, and this is glucose has the lowest osmotic pressure in this case. So option 3 is definitely the correct answer. Be like this, that the correct answer in this case will be option 3. And of course, Option 1, 2, and 3 do not respond to the osmotic pressure. So far, their increasing orders are given here. So these are incorrect. Okay, thank you. We stop here. I suppose you must have got it properly. And please don't forget to subscribe the channel. Thank you very much again.